This video will discuss the interpretation of the definition of the derivative of a function f. We will use this limit definition as h approaches 0 of the expression, which is called a difference quotient, which represents a slope between 2 points. Here's a list of some of the vocabulary mentioned in this video. What is shown here in blue is a secant line. This line is a secant line because it's a line that crosses between 2 points on the graph of f, and it goes through the 2 points located at x, f of x and x plus h, f of x plus h. The slope between the 2 points represents the rate of change from one point to the other point. The red point here located at x plus h is h units to the right of the original blue point located at x. According to the definition of the derivative shown up top, using that notation for f prime of x, we will take a look at the limit as h approaches 0. Now as h gets closer to 0, the distance between the 2 points gets smaller and smaller. Watch what happens to the slope of the secant line as h gets smaller. The slope is readjusting, h is getting smaller, and the 2 points are getting closer together. At this point, there's still a secant line between the 2 points, but the number for h is extremely tiny. Once h reaches 0, the 2 points become 1 point located at x, f of x. It's important to note that this blue line shown is now called a tangent line because a tangent line crosses through only 1 point on the graph of f. This is called an instantaneous rate of change located at that 1 point. So it's no longer a secant line. As h reaches 0, the slope of the secant lines reaches the slope of the tangent line. Let's go over this idea one more time briefly. As h gets closer to 0, the slopes of the secant lines are approaching the slope of the tangent line. And as h reaches 0, the secant line becomes the tangent line. So this derivative up top represents the slope of the tangent line at any particular point, x, f of x. Here's a connection to the actual algebra behind the definition of the derivative. To calculate the f prime of x using this limit definition for f of x equals x squared, let's take a look at it over here. According to the setup, we would find the limit as h approaches 0 of f of x plus h, which we will write as x plus h quantity squared, substituting x plus h into the function f of x, which is x squared, subtracting the function x squared, evaluating all over h. And then performing some algebra here, x plus h quantity squared expands to x squared plus 2xh plus h squared, subtracting the x squared, keeping this all over h. And the x squared will cancel due to subtraction. And then the other terms in the numerator each have an h in them. You can factor out the h, being left with 2x plus h all over h. The factors of h divide out, they cancel out, and then you can evaluate this limit by plugging in h as 0. So we would be left with 2x plus, substituting h as 0, this limit definition of the derivative becomes 2x. So we know the derivative, f prime of x, is 2x. Let's take a look at that previous slide one more time. We have f of x being x squared. We just found the derivative function, f prime of x, is 2x. And if we take that derivative and evaluate it at a point, in this particular graph, we have the x value of 1 shown. Let's plug in x as 1 into the derivative. F prime of 1 is equal to 2 times 1, which is 2. So now we're going to interpret this as the slope. So the derivative function gives you the slope of the tangent line. Now this particular tangent line does have a slope of 2. And if we interpret it as a rate of change, rise over run, on that tangent line, if we rise 2 and run 1, that would give us a slope of the tangent line of 2.